Hello and welcome back to this channel. I know it's been a long time since I last uploaded a video, but unfortunately there were a few obstacles that prevented me from doing so. Anyway, I can finally start uploading videos again. Hope you're happy. And talking about videos, you may show your appreciation if you like this one at the end. First of all, a little disclaimer though. I might have told you on the intro, but I'll say it again, this video has been made solely for educational purposes. I do not endorse piracy on this channel, but with Windows 95 being discontinued for more than 20 years now, and better activation methods being around, and yes, this is the Wikipedia article on product keys, and they even expose the algorithm here, so I assume it's safe to show. And now another, also yet another credit goes to Flytech. Without him I wouldn't even have discovered that algorithm. I've linked both the article and the video in the description so you can do this. And he also challenged to write a little program generating those things, and that's what I'm gonna demonstrate. Okay, that's me editing the video. Please note that I only wrote Jack here, but you will see for yourself. First of all, we need to create a virtual machine, and yes, this is proof that I'm no longer using any of my old stuff. I've used Workstation 12 players and it didn't disappoint, not even when it comes to Windows 95, so just use that. And this is where we temporarily stop. Now we'll open PowerShell. I just call it Win95pk, and this is all we have to do so far. And this is how we get to Visual Studio Code. This is our fresh setup, at least relatively fresh, and we'll make a retail.py script. Okay, so now to the explanation about the Windows 95 retail keys. We have the first 3 digits and the last 7 digits. Both sections are separated by a dash. The first 3 digits can be basically anything. However, you cannot add 333, 444, 555, 666, 777, 888 or 999. This is not possible. Now about the last 7 digits, you need to sum those 7 digits together, and that sum must be divisible by 7. So you see, this would be a valid key. So that be? But how? And this is what I'm going to demonstrate here. And we're gonna store this in the function algorithm. So if we look back to our Windows 95 machine, this is not valid. Okay, shortcuts don't work here. I don't know why, but they don't work. But check out the first 3 digits. We'll split this with a dash. Now of course key sections is index 0 equals any of these 5, 6. I think I do it separately. For the sake of the simplicity, but do in that case we print out and I'll just copy that. So in any of these cases, the key is already invalid. And this is all we have to check in the first section. Now to the second 7-digit section. If it contains 8 or 9, okay, I was wrong. I just checked the script. If it contains 9, it should also return key invalid. Now, and I know I could do better, but this is for your, but this is so you are able to read the code in the first place. It's only how, in order to explain how Windows 95 checks the validity. Well, key sections. We have to do it again. And now we have to define some last digit is 0 and 4 digit in key sections 1. We do some last digits. Of course you could do it like and I don't know if you understand. I'll do the long version here. Right, Python. Int digit. However, you could also do it. You could also do that. This would also be correct. So this is just so that you understand what both that do. From now on, I'll use the short version. This section was just for you to, for me to explain how this even works. Now let's get further ahead. Now, if key sections 1, if some last digits, then we do the modulo 7 is 0. We should return key valid. Otherwise, it's this. We can test this out by doing this. Okay, maybe I should keep valid. This would also be valid. This would also be valid. I put in constant lines, and these are also valid if I replace them with approved numbers, though it's still invalid because 5 plus 11, 13, 20, 4, 32, and that doesn't do it. And by the way, this will also be invalid because I just put 333. However, if I make 135 out of it, it will be valid. So let's try that again in Windows 95. And it works. See that this version of Windows 95 apparently doesn't even care about letters. So in the retail checker there's nothing to do. You can still see, say, key valid or extras. Now it just says key invalid. Oh, we gotta check even more stuff here. like the length of key sections 1 isn't exactly 7, then it's also a fail. This also applies if key section 0 isn't exactly 3. And we can do the same here. So now, if I was to shorten that, key invalid. If I was to shorten that, key invalid. Now there are the OEM keys as well, so let's get through them. First of all, we have 5 digits dash OEM dash 7 digits dash 5 digits. The first 3 digits in the key represent the day of year the key has been created by Microsoft. It can be anything from 001 to 366. And we'll come to the next section. Well, we have anything from 00 to 04 or 95 to 99 in the next 2 digits. This represents the year the key has been created in. Microsoft apparently schedules the keys to be made from 1995 to 2004. And now we come to the joke. You can even use 366 as the first 3 digits if you use a year which isn't a leap year. Now the next 3 characters must be OEM. And now to the next 7 digits. The first digit in the segment must be 0. And on Windows 95, at least according to FlyTech, the last digit in that section may not be 0, 8 or 9. Anyway, in that entire section, the sum of all the digits must be divisible by 7 with no remainder. So just like in retail. And the last 5 digits don't matter, they just have to be numbers. Everything else is your choice. And yeah, this is getting a little bit more tricky. And now we get to OEM.py. We pretty much do the same. Well, as you can see here on Windows 95, on the Windows 95 setup wizard, 5 OEM, then 7, then 5 again. And I'll now tell you why this can be complicated. Typing a key and I did everything else correctly. It was just the 000, and this is why this section, also why this section can be complicated. All you have to do, by the way, if you ask, okay, it doesn't log things. Okay, but we're gonna do this later. For now, Alex will explain what it does. So, key sections 0. And then we have zero, and x0 isn't 0. and also isn't 1, and also isn't 2, and also isn't 3, we have the key is invalid automatically. Same applies if the key selection, if the first key, part of the key starts with 0, 0, 0, then it's also gonna fail for Windows 95. Now we got that out of the way. Now we're gonna do I'll define it here. We have to do approved yes. Five, 96, 97, 98, 99, and then we have 2000, 2001, 2000, and we can continue this until 2004, which is displayed as R04. And we make a ball. And then if key sections 0 dot ends with, if it ends with the year, then we can set can continue to true, and we can break out of the loop. If we can continue, of course, if we cannot continue, it's the usual key invalid. Or I think I'd do it. Because then it cannot continue anyway. It can continue anyway now. The next one is easy. If key sections index 1 is not OEM, then it's also gonna return key invalid. Otherwise, now that we're done with that, let's see what we can do. Same applies if key sections 2 index 0 isn't 0, then the same thing applies. Or if key sections index 2 well, I have to look up 0, 8 or 9. And that's because it's 7 keys, digits. Then we have if seven digits. And we set it to 0. And then we do the same as with the beta version. 4 digit in key sections 2. We do this. Again, this shorter. And if that sum modulo 7 equals 0, or if it doesn't equal 0, we do another key invalid. I know they said it doesn't matter, but we have to do digits. So and now what we can do is print OEM checkout, and then we do the key is valid. And Windows 95 would say the same. However, oops, there's a letter. What do we do now? And that's not valid anymore. So what do we do? So first of all, key sections. Just so that we can use it. So if we run that program again, now we get a letter in there. Invalid. Oops, there's a 0. Invalid. However, if we do this, it's only valid. What does Windows 95 has to say about this? Valid. And that despite the fact that 1995 can't be a leap year, because it's 95 is an odd number. So what do we do about the... Okay, we can remove the digits, I believe. Now if we do the same here, key section 0, it's exactly 5 characters long. Key invalid. Key section 1, we don't need that. Key section 2, we do. And for key section 3, we have 5 again. So that if we shorten that, invalid, shorten that, so this part is unnecessary. So the key is invalid. So this was it for now. If I publish the code I just wrote here onto GitHub, either in this or in an enhanced form, then I will also put the link in the description. So see you next time, goodbye.